Okay, so today we're going to look at tangents, specifically just tangents today and their relationships that they have with the circle, and of course we'll have a lot of problems and stuff like that that come with it. If you forgot what a tangent is, this little definition right here under it, or what it tells us to do, is a good indicator of what it is. So a tangent just hits this circle at exactly one point. We look at it specifically as a line. It brushes right up against your circle at one spot, and that's what it wants us to do to start out. It wants us to draw a line that touches the circle at exactly one point. So we're going to do that. I'm going to start my line, come right up against and hit it in one spot, and then we're going to put a dot right there, and it tells us to label this point B, so we're going to label that point B right there. So this line is a tangent line. And then it says that point B is called, and if you remember back to that amazing PowerPoint that we saw a few weeks ago, we should know that this point is called the point of tangency. And there's something else that happens with the point of tangency. It wants us to draw a radius to point B, so we're going to draw a radius there. And if you remember the relationship that the radius and the point of tangency has, you can do this in a different color because it's important. It's going to form a right angle. So where the radius and the point of tangency meet, or I should say the radius and the tangent line itself, it's going to form a right angle. So in our conjecture down here, it says the angle formed. We're going to write out between the tangent line and radius is a right angle. So we're going to explore a lot of different problems that deal with this, but the point to see right here, that point of tangency right there, and then with your line and radius, it forms a right angle. So that's something that's really important to keep in mind as we are solving these problems. All right, so let's look at some problems that have this relationship. So if you look at number 3, we should see that we have two tangent lines, and they brush across our circle at one point. So at those points, those are going to be right angles. So we're going to fill in our box right here. Wants us to solve for W, tells us that P is the center of our circle and that it has a degree of 140 degrees. So if I look at the shape that gets formed here, I'm going to outline this in red. So here is my shape. This is a shape that we've talked about before. This is going to be a trapezoid. Specifically, this is not trapezoid. It's going to be a quadrilateral. Specifically, this is going to be a kite. So we talked about this way back, but we have a kite. But the important thing to see is that it's a quadrilateral, so it equals 360 degrees. If I look at this more specifically, I should see that I have one angle here, another angle here, another angle here. So to be able to figure out what W is going to be, I'm going to take 360. I'm going to subtract all those angles that came from it. So we have that 140, and then we have 90. So all of that we're going to subtract out from that 360. When we do that, we're going to get that W equals 40 degrees. So that angle right here is a 40-degree angle. So this should kind of look familiar with some of the stuff that we just took a quiz on, but if you notice, they don't give us any arc links. They give us some other stuff, so what we learned previously wouldn't help us necessarily in that case. But use what we know about right angles that get formed, boom, we get 30. So if I look at number 4, we should see that we also have a quadrilateral in this scenario. This time I have two circles next to each other and then a tangent line that hits them both in one spot. So again, that spot that it hits it at is going to be right angle. So we're going to put our little boxes there that establish that. And let's go and solve for our missing angle. It gives us a 70. We're solving here for Z. So I'm going to take 360 degrees, subtract out each of those 90s, and then I'm going to subtract out that 70 degrees. So after I do that, I'm going to get X equals 110. So 110 degrees is going to be my angle right there for Z. And keeping this train rolling into number 5 right here, I should see that I still have a tangent line even though it doesn't look like a line itself. I see a triangle get formed. But this line up top only hits my circle at one spot. So if I kept this going, it should look like all the other lines that we've had. So at this one spot, I'm going to get 90 degrees. I got 34 degrees here. we should recognize that this is a triangle, and a triangle has 180 degrees. I'm going to subtract out 90 right here. I'll subtract out that 34. Type that onto my calculator, and I'm going to get x equals 56 degrees. So these are the types of problems that we're going to see when it comes to tangents, and of course you'll see problems like these on your test in 2 weeks. All right, so let's take a look at number 6 right here. So we should see we have another triangle again. It's safe to assume this is going to be a right triangle, just like we saw in number 5. Now this one tells me I got 45 degrees here, so it's easy to assume that this other angle here is going to be 45. If I look, they give me the hypotenuse, and that hypotenuse is 23 radical 2, and I need to find x, which is going to be a radius. So here's a flashback to the beginning of this semester. This is a 45, 45, 90 triangle, and I'm sure we did not forget our rules with a 45, 45, 90, but just in case we do, if we have our hypotenuse like we do in this situation, which is 23 radical 2, if we want to go back to our leg, we would have to divide by radical 2. So in that case, we get 23. So 23 right there is going to be the answer to our, for x here. Each of those legs is going to be 23. Of course, if you plug this into Pythagorean theorem, we would get this 23 radical 2. Moving on to number 7 here. So again, I see a triangle. And again, like I talked about earlier, like I mentioned in the last problem, we should see that this is going to be a right triangle, so we can safely assume that. So I got 90 degrees there. It wants me to solve for y right here. It doesn't tell me what this angle is right here straight up, but it does tell me that I got 130 degrees on this side. So I should see if I have 130. Then on this other side, I need to subtract from none other than 180, like we do a lot of the times. That's going to give me 50 degrees right there. So 180 minus 130 gives me that 50. So I got 90, I got 50. I'm solving for y right here. So I'm going to take my 180 minus 90 minus 50, and we should see that we get 40 degrees right there for y. Last one is, we're on this front side, numero ocho right here, number 8. We're going to change this problem up a little bit. Instead of having this little part as 4 and have that be x and get a little dramatic with it, that's not going to be 4. What I'm going to say, let me write this a little better. Take out that 4. We're going to say that this entire hypotenuse, spoiler alert, that's our hypotenuse, is going to be my favorite number here, 10. So that's going to be, hypotenuse here is 10. We're going to have a leg right here of 8. I need to figure out what the radius or the other leg of this right triangle is going to be. So of course we're going to use our best friend Pythagorean theorem to help us out to figure out what that missing leg is going to be. Like I said, 10 is the hypotenuse, so we're going to have a squared, which we're going to say a is going to be x, b squared, which we're going to say is going to be 8, equals 10 squared, and then we're just going to solve for x. So we're going to get 64 equals 100, subtract that 64 from both sides, so x squared equals 36. Take the square root of both sides to get x by itself, so x equals 6. So our final answer here is going to be 6 for number 8. All right, so moving on to the top of our back page, we have one more concept that we are going to explore here. So what we have going right here tells us to draw a tangent line from point A to the top half of circle O, and we're going to label that point of tangent CH. So I have my line, it's going to hit about right there. I think that's pretty good for hitting the top half of our circle. We're going to call that point H. And then it wants us to do the same thing again, except this time at the bottom half of your circle, we're going to call this point of tangent CG, where they touch at, so right there. Not as good as that first line, but we're going to get G. So what it wants us to do is measure the distance for both line segments. So in this case, we would take a ruler out and measure it. Obviously, we're not going to do that, but if we were to take a ruler, we would discover this super amazing, awesome correlation between these two, is that these are congruent. So of course, we'd write in the measurements for AH and AG. So what we're going to see here is that AH is going to be congruent to AG. These two line segments are that. Or I guess it would be lines, but in this case we use them as line segments. But we're going to see that those two are going to be congruent with one another. So our conjecture that we are going to see here is that two segments, or segment tangents, which is what we have in this situation. So I'm going to kind of underline that and say that that's what that is. To a circle from a point outside the circle. So in this case, the point outside the circle is A right here. Are congruent. An exclamation mark. We're excited about this. So if AH hypothetically was 15, then AG would also be 15. So those are going to be congruent. Of course, you can kind of see some of the problems that we could come from this, but this is our conjecture from it. If we have a point on the outside, we have those two segments that hit your circle. Those are each going to be congruent with one another. So let's look at some problems that explore this relationship so we can kind of get an idea of how easy this can be. All right, so let's take a look at some problems that deal with this new relationship that we have, or that we just found. So if we look at number 10, we have x that we're looking for here. So here's our 74. We see that AR and AS are our tangent segments that end up having that relationship that we discovered where this and this are going to be congruent with one another. We should see that when we do that, this forms an isosceles triangle. So if you remember an isosceles triangle, that means that two sides equal each other, and if two sides equal each other, that means that the opposite angles are going to be congruent. So I need to figure out what x is. It tells me I got that 74 up top. So it's a triangle, so 180 minus 74. So I get 106. That means that between these two angles right here, they need to add up to equal 106. They also need to be congruent with one another. So 106 divided by 2, that's going to give me 53. So 53 degrees right there for x. Number 11, I think that's as easy and straightforward as it gets. Here's my tangent segments. I'm going to put those tick marks there to establish that they are equal to one another. So I'm going to get 3x minus 6 equals x plus 10, and then just solve for x. In a situation like this, we want to be as smart as possible, avoid negatives. So a good start would be to subtract x from both sides. I got 2x minus 6 equals 10. Add 6 to both sides. So we're going to get 2x equals 16. Of course, divide both sides by 2. X equals 8. So 8 would be our answer there. Of course, we can plug that back in to double check to make sure they just equal each other. When we do that, we get 18. Let's look at number 12. So it wants us to find x. So if we look at where x is the entire segment of DB right here. So I need to figure out what that segment is going to be. So we're going to kind of break this problem up. If I look, it tells me that from B to A right here is 3. So if I know that that is 3 there, I can safely assume that BC is also going to be 3. So this little part right here is going to be 3. So let's look at this bottom half of the triangle. It gives me ED right here. ED right here is going to be 4. So if I know that that's going to be 4, then I can safely assume that DC right here is also going to be 4. And then if I look at this, I got 3 taken up there, I got 4 taken up there. Do some big brain math and figure out that X right here is going to be 7. So 7 is going to be my answer there. So just knowing that relationship, that those are congruent to each other. Problem that looks kind of scary looks like that it's going to work out to be a very easy problem of 3 plus 4. Now speaking of scary, looks like number 13 would be exactly that. If I look, I got some trinomials right here. So first thought is probably, hey, let's factor this. But what we're going to do, we should know the relationship between these. Those are going to be equal to one another. So we're going to set them equal to each other. It's going to look ugly and scary, but it's actually going to turn out to be a very nice and easy problem. So we set those two equal to each other. What's going to happen in this situation, and what makes this such an easy problem, is that if I subtract an x squared from both sides, looky there, those are gone, but bam. Now I got 8x minus 20 equals negative 4x plus 12. So those x's, or those x squareds, eliminate each other, they're gone. Now from here I'm just solving for x. You've worked problems like this before, so hopefully this isn't scary. Might be some scary to some of us, but we've tackled problems like these. Again, I want to stay positive, so I'm going to add this 4x to both sides. So I got 12x there. I'm going to kind of save myself some room. I should see that my next step here is going to be to add 20 to both sides. So I'm going to add 20 to both sides and get 32. So I got 12x equals 32. I'm going to divide by 12. Probably the scariest part about this problem is that we get a decimal. We're going to get 2.6 repeating in this situation. So if you type that in your calculator, you should get 32, or when you do 32 divided by 12, we'll see that we'll get that as our answer. Before the question gets asked, will you see problems like this on a test or anything? Probably not, more than likely not. But the whole point is to show you that a problem like that looks scary, not actually going to be the case. Those x squares cancel each other. Of course, there's a deeper metaphor of not to judge a book by its cover. But anyway, let's move on to number 15 right here and wrap this up. 15 wants us to find the perimeter. So this looks a lot like the problem that we just did in number 12, the one right above this. It tells me that OR right here is 13. This is 13. I should see that this is going to be 13. If I follow the tick marks, one tick mark here, that means that OA and AK are equal to each other, so that's going to be 13. Well, if that's 13, guess what this is also going to be right there? That's going to be 13. So I got 13 all around. If I look at my RS right here, so that tells me that's 12, so I'm going to put a 12 there, two tick marks here, so that's also 12. I should see that those are going to be equal. These are going to be 12 as well. So it wants me to find the perimeter. Perimeter is simply just adding all of our sides up. I should see I got 4 13s. I got 4 12s. So this right here can go into your calculator to get an answer. It's going to be a very, very nice answer of 100. So 100 is going to be your perimeter there. So this is the lesson that we have today. Really just two concepts that we looked at, where we have segments equaling each other coming from a point outside of the circle. So that's what we just worked on. And then, of course, we saw in the beginning of class something that we talked about from that amazing PowerPoint that we did a few weeks ago, that we're going to get a right angle that gets formed from the point from our tangent and from our radius. So this is our notes. You're still going to have your in-class practice to do and then quizzes. And then completing all of that will ensure you to get 5 bonus points on your test when you take that. So make sure we get that taken care of. So that's going to be it for the notes. Go and tackle everything else, and then you'll be good to go for today.